talk about binary search. In the previous video, we talked about a linear search and we know that it worked on unsorted data. But a binary search work on our sorted data, and that too not in descending but in your ascending order. Ascending smaller to bigger. Okay. Now second thing is that it is a lot more faster than your linear search. So faster than your linear search. Now by definition, when I'm speaking, by definition, instead of checking every element it keeps cutting the search space half each time. So this is the definition that I hope you must have written in your notebooks or notes, whatever you're making. So this is the definition of how it works actually. So let's take an example. You got a list that says 2, 4, 6, 8, 10, 12 and 14. Okay. Now we're going to consider that our target is the number you're looking for, right? So target, supposingly it is your 10. Now we find the middle index, middle element, that is 8. Okay. Now what is the index? 0, 1, 2 and 3. 3 is my index. So I'm considering it as my middle element. The first step. So I got my middle element. Its index is 3 and value is 8. My target is 10. Since 8 is less than 10, therefore it will search in the right direction because it is arranged in an ascending order. So it will know, my algorithm will know that now it's need to search in its right direction, because in the left the numbers are already smaller than the targeted one. So now the second list that is going to consider the right direction is 10, 12 and 14th. Now its middle number is 12. Index, okay. Now let's just consider it as index 5. Sorry, it is at index 5. Now my 12 is greater than my 10. Again, it is not my value that I require and it is greater than my value. So now it knows that it is somewhere in the left direction. Now it will go in the left direction and the list that it is going to consider is your 8, 10 and 12. Now here in the middle it finds the 10. Okay, now I'll explain it again. The numbers were your 2, 4, 6, 8, 10, 12 and 14. Okay, this was your middle number. Okay, and this was less than 10, so it jumped to the right direction. Now at the right direction, my 12 was my middle, but 12 was greater than 10, 8 was less than 10. Now it jumped to the left direction again. So that point, in this point, it considered this as the primary set. When it jumped to my right direction, it considered this as my primary list. Now when it is again jumping to my left direction, it will consider this as my primary list, and here I'm going to find my 10. Now 10 was my middle number. This is the concept of your binary search. So it is something that works on sorted data and it is very fast on your large data sets. It is an advantage because my linear search was slow, but it worked on your unsorted one. Meanwhile, the binary is fast and it works on your sorted data. So this was all about your linear search and your binary search. And linear I told you in the previous video, and here I'm telling you about your binary. So now we'll code a simple code with this data set only, with the numbers I told you. Okay, so hash include we have already written, and all these statements are already there, so we need to define our thing. So let's just define our array first. So int array is equals to 2, 4, 6, 8, 10, 12. Okay, now many of you must have a doubt that this is or even odd amount of numbers. So you get 8 as your middle number. But in case of your even number, supposedly there are 6 numbers. So we are taking integers kind of division. So we are going to find mid by left plus right divided by 2. So the left hand side position is going to be favored. I'll explain this to you. Supposedly I have my, these numbers only. I get 2, 4, 6, 8, 10. Yeah. So these are my 6 numbers. Sorry, 1, 2, 3, 4, 5. Yeah, 12. So in this condition, 1, 2, 3, 4, 5, 6. What will be my middle number? So I'm going to consider my left element index and my right index. Okay, that is my 0, 1, 2, 3, 4, 5. 5. So 0 plus 5 divided by 2. That would have been my 2.5. Okay. But in this condition, the point is I'm using integer division. In integer division, the decimal holds no value. So my second index is going to be my middle number. Okay. So this is the case. Yeah. I'm going to consider my 14 as well. Right. 2, 3, 4, 5, 6, 7. Let's just make it. Okay. I'll just take a look here. Let's just keep it like this. Yeah. Now, I'm going to consider my int n. N is the number of integers, that is your 6. It is not the values, it is a number of, it is not the index, it is a number of integers. Then I'm going to consider my target. My target is of course my 10. And then we are going to take into consideration int left. The index of left is my 0. And then right. The index of right is my n minus 1 because index starts from 0. And then I'm going to consider a mid. Okay. And then my found is equals to minus 1. As explained in the earlier video as well, found can be any value. We just need to check. But of course, any other value could have been the value of your, it just needs to ensure that the values that are present in your array is not in your found. Okay. So now I'm going to use my while loop, because while loop runs infinitely until your statement is false, of course. So I'm going to consider while my left is less than equals to right. Because if in case my left is greater than right, that means my list or my array is in descending order or is unordered, is not in ascending order, is not sorted as we require it to be. That's why, okay? So we are going to consider mid is equals to left plus right divided by 2. Integers division, of course, right? Then I'm going to consider if your array, and in array I'm going to consider my mid, of course, is equals to target. So if my array is my target, if the mid of my array is my target, of course the condition is fulfilled, and I'll say my found is equals to my mid, right? And then I'm going to go with break. Yeah. But then else if, okay, else if my array mid, of course, is less than my target, in that condition my left becomes my mid plus 1, because since my mid is less than my target, that means my target is going to be in my right position. So I need to increment or go into the right part, right? Yeah. So I do mid plus 1. Now I'll go with my else. Else, I'll just make it look more structured. Yeah. Else, I'll consider my right is equals to mid minus 1, because other condition is that my mid of the array, middle number of my array, is more than the target. Then I need to move towards the left direction. So I'll consider my right is equals to mid minus 1. I'm considering left is equals to mid plus 1 because left is my 0. So 0 plus 1, I'll go to my right direction. And right, the index is my extreme value. So if I decrease the number from it, I'll move towards my left side. Yeah. Terminators. And of course, after break, I forgot the mid also, I guess. Yeah. Yeah. Terminators. Yeah, there. Yeah. Yeah. So of course, okay. Now I'm going to say my if my found is not equals to my minus 1 that we considered, in that condition we'll say that printf found at index %d comma found, whatever the value found is according to our loop, right? Now the else condition states else printf not found. Yep. So we are done with the loops, we are done with our conditions. Let's just run it. Okay, break statement not within the loop of my switch. Okay, so I should just maybe we made an error. Let's just do it. Break. Okay, let's remove it. I guess it's not needed. We'll just remove it. Yeah. Running. What happened? Let's just wait. So we'll run it again. Let's see. Yes, there was a network error. We got a result that index is at 4. 0, 1, 2, 3, 4. Now I'm considering that I remove my 10 in that condition. What am I going to get? Not found. If I keep my 10 here, then let's see. Yeah, not. Yeah. Oh, sorry. Yeah, then let's see. Two. Yeah. 0, 1, 2. Yeah. So we got it. That's it.